So if I know how to graph linear functions in slope-intercept form, then I can solve systems of equations by graphing. What that means is if I create a graph independently for each equation or each table, if that's what they give me, or each scenario, then I can put those equations on the same graph and I can see where those equations cross, and that will give me the solution to a system of equations, which is just more than one equation. So let's look at each of these. So if I'm given this equation, which is y equals x minus 3, I'm going to start off exactly the way I started off those other graphing problems. So I'm going to think about what is my y-intercept. My y-intercept is the number not attached to the x, and it goes on my y-axis. So in this equation, my y-intercept is -3. Then I need to think about what my slope is. Your slope is the number attached to the x. If there's no number there, then you have an invisible 1. So I know that my slope is 1/1 for this first equation. And it's positive because there's no sign. So when there's no sign, it's an invisible plus sign. Then I'm going to continue my graph. So if I've got a slope of 1/1, the numerator tells me how much up or down. We're going up in this case because it's positive. And the denominator tells me how many units to the right. So I go up 1, right 1. I'm going to repeat this a few times because I'm now thinking about where these graphs are going to cross. So it's extra important to have a perfect line drawn because this is what determines the answer. So if your graphs aren't drawn correctly or there's just a little mistake, then you won't be able to see where they cross. So I graphed that first equation. That's what I needed to do. Now I'm going to graph my other equation. My other equation is y equals -1/2 x plus 3. So I'm going to identify my y-intercept, which is +3. So on my y-axis, I'm going to go to +3. And then I'm going to use my slope to continue that line. My slope is -1/2. As we said in the last video, when you write out your slope, you want to give the numerator the sign. The numerator tells me how much I'm going to go up or down. If it's negative, we're going down. And the denominator is how much I'm going to the right. So in this case, I'm going down 1, right 2. Down 1, right 2. And see how they cross at this point? So let me connect my dots and extend my line. And I know then that the solution to this system is where these points cross. So the solution to this system is the coordinate 4, 1, because it's this coordinate right here. I'll use a metallic Sharpie so we can see it. No, doesn't make a huge difference, but that's what it is. So you're just looking for where they cross. We call this having one solution. If the lines cross, we have one solution. There are two other types of solutions you can have when you're dealing with a system. You can have one solution, but you can also have infinite solutions and you can have no solution. So it's just like when we're solving equations, you can either have an answer, not have an answer, or have all the answers. So let's look at examples of the other two. So if I have a system of equations, where the first equation is y equals 3x plus 1, and the second equation is y equals 3x minus 2, I'm going to start the same way I did the last one. I'm just going to do one equation at a time. This first equation has a y-intercept of positive 1, so I'm going to plot a point at positive 1. It has a slope of 3, which means that we have a slope of 3 over 1, which means that I'm going up 3, right 1. So I can continue this line by going up 3, right 1, and put a point. Then we're going to connect our dots, make sure we're drawing a perfect line. Which I am struggling to do right now. Okay. And then I can move on to my next equation. The next equation has a y-intercept of -2. So I'm going to go to -2 and put my point. It has the same slope actually. So we've got a slope of positive 3, which means my slope is a positive 3 over 1, which means I'm going up 3, right 1. So starting from that y-intercept, I'm going to go up 3 and right 1. I can fit a couple more dots than I could in the last one. And then I'm going to connect my coordinates. And I'm going to notice that I have parallel lines. So when my slopes are the same, but my y-intercepts are different, I end up with parallel lines. Parallel lines never cross. So if they never cross, there can't be a solution because my solution is when they cross. So if I have parallel lines, there is no solution. So this is parallel lines. And we know that parallel lines have the same slope and different y-intercepts. I'm just going to write B. So that's our no solution. Now we have one more example. Just like the other two, we're going to start off the same and just start with one equation at a time. I am going to identify my y-intercept, which is positive 1. I'm going to go to this positive 1 and I'm going to put a point. I need to write out my slope so I can easily continue my graph. My slope is -3 over 2, which means that I am going down 3 and right 2. So I'm going to start at my y-intercept and go down 3, right 2. I can create one more point, I think. And then I'm going to connect my dots. And extend my line. This next equation isn't simplified enough for us, so before we can take out the information we want, let's just distribute that number on the outside of our parentheses. So this, I'll write it down here so it's a little bit, no, I need that space. Okay, so we're going to do the distributive property. -3/2 times x just gives me -3/2 x. -3/2 times -2/2 gives me +1. I'm going to graph this just like I did the last one. My y-intercept is 1, so I'm going to put a point at 1. My slope is -3 over 2, which means I'm going down 3, right, 2. So we're going to go down 3, right, 2. And then we're going to notice something about this. What's happening is I'm actually graphing the exact same line. So when I connect these dots, I've just got the same line. I didn't even have to put it into a graph to figure that out, because when I look at those initial equations, I've got the same exact equation. So I've got y equals negative 2/3 x plus 1. And then once I distributed that number, I had negative 2/3 x plus 1. When my equation is the exact same, I have the exact same line, which means they are constantly overlapped. There is no point at which they're not touching. So the solution is just infinite. So we're going to write infinite solutions. So this happens when we have the exact same line. So not only is the slope the same like when we had parallel lines, but the y-intercept is also the same.